we are presenting ClaimCheck, which is a new tool to identify and counter potential false claims when they are repeated. As Matthias said, we are a team of journalists and engineers from ABC Australia and Newtral in Spain. We have been working in ClaimCheck for the last 6 months because we wanted to create a multilingual artificial intelligence tool to detect when a politician is repeating a false claim and then alert journalists. But our fact-checking teams, as many other in different parts of the world, have detected that the politicians keep repeating the same key points over and over again, and this information keeps being spread many times, many different times. The problem is that people usually use different words when they want to express the same idea. So why is this a problem? Repeated disinformation steals time and effort from our fact-checking teams that need this time to verify other disinformation that is going to be spread on the social media. And also, the use of paraphrases and different wording makes it more difficult for technology to detect similar ideas. This has also other consequences or effects. For example, repeating a lie makes people think it is true, reinforcing the illusory truth effect. Second, repeated false claims or measuring repeated false claims is a way for us to identify intentionality in political discourse. And also, effective monitoring can help hold politicians accountable, since the evidence tells us that it's more effective when the person who said the false claims corrected himself. So we wanted to create a tool capable to do these 3 tasks. First, matching claims with previous fact checks already published by our outlets. Second, clustering similar claims all together. And third, detecting disinformation strategies when the same false claims were being repeated by different actors or people. So by doing this, the tool could help journalists to monitor large amount of social media data. At the same time, it would help to save time and efforts, and it could help us to respond faster to our audiences, which in fact-checking is quite relevant to stop the disinformation. So again, what is ClaimCheck? ClaimCheck is a multilingual tool. We use it in English and in Spanish for journalists that uses artificial intelligence to quickly detect potential repeated false claims made by politicians on Twitter by matching them with previous published fact checks, and then alerting the journalist and the newsroom through a channel on Slack. In different words, ClaimCheck is a sentence similarity model built on the foundation of Claim Hunter, which is a different algorithm that filters check-worthy claims that contain factual information, and a claim matching tool that provides previous fact checks as references. So how does it look like? We have prepared this video to show how are we using this tool in our newsroom.
Fact-checkers working in our teams verify dozens of claims every day. They check articles, press conferences, speeches, interviews, and many other political discourses. ClaimCheck is a tool that aims to detect potential repeated false claims on social media. It builds on the foundational tool Claim Hunter, which detects claims on Twitter. When a claim is identified, Claim Hunter sends an alert to the journalist or editor through Slack. Fact-checkers then either reject the claim if it doesn't contain factual material that can be checked, or they select review if it does. When the review option is selected, the tweet is sent to another channel where the journalists begin further fact-checking. ClaimCheck adds a new layer to this automated process. When there is a similar claim from a previous fact-check or another tweet, it alerts the fact-checker that this additional information is available to quickly help fact-check the claim and debunk potential false claims and disinformation.
So, by doing so, we believe that this tool can contribute to fact-checking on a global scale. But achieving that wasn't easy, and my colleague Gareth is going to explain how we did it.
Great, thanks, Irene. So yeah, I'm Gareth. I'll talk a little bit about the technical sort of components of our system. So what's the sort of simple version? Well, really, we're labeling, this has been about the labeling of claims and verification pairs to improve the accuracy of our model outputs. From a technical perspective, really, we've been ranking similar claims and verifications using mean average precision as the main optimization metric. The next slide, please. But let's take a bit of a step back and look at this sort of high-level diagram of our system. So on the left, we've got the claim hunter component that's doing the checkworthiness detection of tweets, where politicians' tweets are monitored, and then a model tags the tweets as checkworthy or not. And then on the right-hand side of the diagram, you've got the claim check component, and that's, as Irene mentioned, been our focus over the last 6 months. On the top there, you've got our data labeling process. So the claim and fact check matching process is on the bottom. How this kind of works is we've got two labels, similar and dissimilar. We label according to our annotation guide, review the labels, store them in the database, and then use that sort of data set to train the model, and then surface matching tweets and claims through the Slack interface that you've just seen. Next slide, please. So yeah, how does it do that? So we've got a human labeling process, but also an automated labeling process. So to drill into that in a bit more detail, we use a machine learning model to generate an embedding or a latent representation of the tweets and claims. And then we compare the similarity of these embeddings to get the tweet and fact check pairs that we care about. Next slide, please. So drilling down again a bit more into that automated approach, we've taken three different approaches, run experiments for each. The first using a sort of heuristics, so human-defined rules, if then else, sort of fed into a classifier. The second approach compared the embeddings that I talked about in the previous slide and defined a sort of similarity threshold, so just a real number, compare these two embeddings, and you can define a cutoff point for similar or not similar. And then the third approach that we tried was a combined approach, so combining the embedding and the classifier. That gave us the best results. The conclusion being that, of course, we see again human expertise in data labeling and letting the sort of machines learn from that. High quality data is what gives us those good results. Next slide, please. Moving now to key takeaways. The key takeaway from the ML modeling perspective, perhaps unsurprisingly for some in the audience, is that modern transformer-based deep neural networks are very effective for solving this kind of problem. And we evaluated a number of BERT-like models. This is research that was initially done at Google, although kind of has become the de facto standard in NLP. So a couple of models there from Microsoft and the open source XLM Roberta. Next slide, please. So key takeaways from a trial or experiments perspective. So we had over 7,000 pairs in our training sets, 66% of which were similar claims. Our benchmark data set for evaluation had over 2,000 pairs, 45% similar. Generally speaking, both models had sort of good precision and recall. However, the compute requirements, which is kind of important to consider when you're actually serving this stuff at scale, compute requirements for the Microsoft model were lower, so it made sense to, which meant sort of simpler to implement, cheaper to run, and it made sense to put that into production. Next slide, please. Key takeaways from the editorial perspective. This is very key. As I mentioned, high quality data is critical to the accuracy of our outputs and kind of everything for our project. So those data labeling and annotation guidelines were key. They needed to be editorially consistent. We needed to involve trained journalists. We're teams working across organizations, time zones with different kind of experiences. So getting consistent labeling results was really important to our performance here. Next slide, please. So to drill down into even more detail, please take a look at our link to our site on Notion. That should take you through some more of the detail. But otherwise, that's pretty much it from us. So final slide. Here's Irene. Thank you very much for your time.